All right, so I'm going to start out by going over some of the questions I've been asked via email. So first question I've been asked, will we be expected to manipulate data on graphs or in Excel on the tests? The answer is no. It's unrealistic to expect you to be able to take data and process it in Excel during the course of an hour and 15-minute exam. The graphs you need will be provided to you. It is up to you to understand how to read those graphs and how to interpret those graphs. But you will not actually have to generate an Arrhenius plot or take raw data and convert it. Second question I got asked, could you go over how to identify catalysts in a given reaction and what makes those reactants the catalysts? So if you go to the test tube packets, and we'll work with one of the more involved ones here, scheme 4. So let me share my desktop with you. So here we've got nitrogen-oxygen reaction to give us NO2 nitrogen dioxide. And the question is, what are the catalysts and what are the intermediates? Well, first of all, what are the intermediates? These are the easiest ones to tweeze out. So the intermediates are first formed as products. In this case, we've got ruthenium 3 nitride, because it's first a product, then a reactant. Same thing too with the iron 3 oxide, that's first a product, then a reactant. We've got the ruthenium, I don't know what that compound's called, the ruthenium with the NO3 NO on it. So those are our intermediates, the easiest ones to tweeze out. Your catalysts are things that first start out on the left side of the reaction arrows, and then they're going to appear on the right side when you're done. So to identify those with this compound, if you look at N2, N2 appears as a reactant once, and it's never seen as a product again. O2 appears as a reactant, and is never seen again in the reaction. The ruthenium, Ru, is definitely seen on the left side first, and then it finishes on the right side as ruthenium. So that would be a catalyst because it's first a reactant and then a product. Same thing's true with the iron. The iron starts on the left side and finishes on the right side. Now, a few comments which I see in terms of confusion with students, the numbers in front of a molecule don't matter for the compound. 4 beside ruthenium is not any different than 2 beside ruthenium. That's just the number of ruthenium atoms. The numbers that matter in telling the difference between whether two things are the same in a reaction are those subscripts. So if it were Ru2 and Ru3, those would be different phases of ruthenium, but the reaction coefficient in front of it has no bearing on what the identity of the compound is. The third question, could you do a half-life of a chemical system example problem like those in the study guide? So if you go to the study guides, and let's drop down to the last page. For half-life problems, these are simply a matter of applying the half-life formulas. So if you take a look at any of the last 3 on this page, they're all given as K is 0.123 with the appropriate units. And the starting concentration is given as 1.23 for all these problems. So the way you solve for the half-life is that it depends on the actual order of the reaction. So for a 0-order reaction, the half-life, T sub 1/2, is starting concentration over 2K. For a first-order reaction, it is ln of 2 over K. And for a second-order reaction, it's 1 over starting concentration times the rate constant K. So for any half-life problem, you're just going to take these formulas and apply the numbers you're given. So we would apply K here and the starting concentration, and we get a number back out. In terms of the actual units on that reaction, what we would do is the units on the half-life, that would be set by K. So if K is in per minutes, the half-life would be in minutes. If K is in per hours, the half-life would be in per hours, and so forth. Now, the only way to make these any degree of difficult is to ask you to solve for K, which pretty much in all cases you're just going to swap the K and the T 1/2 by algebra. And again, you're just going to plug in the numbers that you're given. Now, I also have another set of questions from another student. Just a minute to bring those up. So the pre-exponential homework questions 1 and 6, could you complete these live? In terms of, so the questions also in here, my answer to the test you study packets are off. As long as you're within like 2 to 3%, your answer is probably correct, especially if you're doing it with a calculator. The thing is, Excel carries about 100 decimal points of your precision. Your calculator only carries about 10. Because of that, you will see slight deviations away from your answers versus the packets. That's fine. But again, I've been asked to go over some of the problems on page 5. But the pre-exponential factors 1 and 6. I'm guessing it's 1 and 5 because there's only 5 cases. So they're all pretty much solved the exact same way. So let me share my desktop with you. So we need 1 over temperature in Kelvin. Now, some people have been adding 273.15. The thing is that your temperature is not in that many decimal points per revision, so you need to be leaving off that 0.15 and just do 273. Otherwise, you're going to get a slightly different answer, which Web Assign is going to catch. Natural log of the rate constant K. So you can plot natural log of K versus 1 over temperature in Kelvin. Add your linear regression. So down here we'll put the slope M, the y-intercept B in this case. The slope here is minus 4409.3 and the y-intercept is 7.2208. Again, this is for case 1. To find the EA, it's the negative of R, negative 0.008314, times the slope. And then for the pre-exponential factor A, it's just the exponential of that number. Now again, you're going to have to go to 3 significant figures. So when we do it with this one, we get 37.1 for the activation barrier, kilojoules per mole. For the pre-exponential, 1370. So if we go to the assignment itself, you see that? Course case 1 is the last one. So we have 1370 as the answer and 36.7 is the activation barrier. 36.7. That's odd. I'll need to look into that, but that should not be giving you that answer. Oh, 8.314. Ha! I did it wrong. So it's 36.7, which is what the answer is for the assignment. As for case 5, which is the first problem in the homework, it's the exact same analysis. So we do 1 over T, natural log of K. So go ahead and get the Arrhenius plot. Okay. So we need a minute to generate the plot. At the trend line. And I can just do the same analysis I did before. So I just need to know the slope and the y-intercept. Slope here is minus 6527.6. and 8.4471 for the y-intercept. So that gives me 54.3 for the activation barrier to 3 sig figs and 4,660 for the pre-exponential factor. And if we go to the homework, that's what we see, 4,660 and 54.3 for the activation barrier. Now, in terms of the packets, page 5. So we'll work the first question and the last question. What is the concentration of O2 at the consumption falls 0 or connects, and the starting concentration is 0.650, the rate constant is 0.320, and the time is 0.776 hours. So if it follows 0 order kinetics, the connection between concentration and time is A equals A naught minus KT. In this case, A, our species, is O2. Starting concentration is 0.650. Rate constant K is 0.320. And the time here is 0.776. So I'm going to plug that into Excel really quick. So the number I get is 0.402 molar. And if I compare this to the key, yeah, it also gets 0.402. Now the last question on page 5. What is the concentration of bromine at the consumption of bromine? Br2 follows second order kinetics with a starting concentration of 0.76 molar, a rate constant of 0.93, and a time of 7.3. So to solve this type of problem, again, we need to write out the connection between concentration and time. So here we have 1 over A equals KT plus 1 over A naught. In this case, A is Br2. So 1 over the concentration of Br2 equals K in this case, which is 0.93 times 7.3 plus 1 over 0.76. To solve for Br2, we just take 1 over that entire number. So 0.93 times 7.3 plus 1 over 0.76. If I plug that into Excel, times 7.3 plus 1 divided by 0.76. I get 0.12 molar. And the key also shows 0.12 molar. So if you've got something like 0.11 or 0.13, you're fine. The bigger, especially when you start getting to these really high precision numbers like 0.1722, if you're getting 0.173, that's fine. It's more when you start getting within that 10% range, particularly for 3 significant figure answers, that's where you need to start worrying about what your actual work is. So corrections have actually been for page 6. So page 6 is more or less just the exact same problems. You're just solving for a different variable now. So it's more of an exercise of how well you can do the algebra. So we can work the first problem, and I'll bring that up. So if a reaction is 0 with respect to CO2, then determine how long it took for the concentration of CO2 to decrease 0.7 molar. The starting concentration is 1, and the rate constant is 0.0189. So again, we're just going to write out our connection between concentration and time. So we get the concentration of CO2 equals the starting concentration of CO2 minus KT. The question asks how long, so we're looking for time here. So we're going to get starting concentration of CO2 minus final concentration of C2 all over K equals the time. So if we take, based on that formula, 0.33 divided by 0.0189, we get 17.7 or 17.5. And K is in minutes, so it's going to be 17.5 minutes. And if we compare this to the solution set, there's something in wrong. Oh, 0.23. 12.169, or 12.2. So for the problems on page 6, this is more just an exercise in algebra more than anything else. There should be homework for test 3. I'll check to see why it's not up. It should be visible at this point, but there is definitely homework for test 3. Now, as far as getting like 12.2 versus 12.3, as I said earlier, if you're with, because 12.2 versus 12.3, that's 1% error. I would not worry about anything less than 5% error. That's more going to be a reflection, again, calculator, a typical handheld calculator is only going to carry 10 decimal points of accuracy. Excel is going to carry something like 100. So if you do have a complicated number, it's going to get slightly off. It can also be a reflection of intermediate rounding. But definitely if you're within 1 or 2%, you got the answer correct. You're probably just seeing more issues of intermediate calculations than anything else. Now, a big thing on the homework for test 3, there's a series of questions that do not appear on WebAssign that will be on the test, and these are questions related to thermodynamics, so the free energy calculations. There is going to be a discussion board on it, but you're going to have to go to the packets on the course website. When you see these questions, you'll understand why they're not WebAssigned. They are incredibly hard to even write out by hand, something like Word. It gets even more daunting if you do something like WebAssign. And particularly with these types of calculations, because there are so many intermediate calculations, it quickly devolves into having a spectrum of answers that WebAssign just can't handle. Like, it's just too much to deal with. So with the free energy calculations, the delta H and delta G calculations by adding and subtracting reactions, those are something you're going to have to do by hand, but that's why the keys are up, as well as the practice problems. They're also the kind of things that when you see how these problems are worked, both in the videos and the notes, you're going to see that there's a lot of manipulation, there's a lot of algebra. It's kind of hard for you to take something like that off a computer screen and try to like work it through WebAssign. It's a lot better if you have something like a Word document where you can like work it in the document. Although I really am curious because on my end it's not showing any test 3 questions either. Looks like they'll be visible tomorrow for some reason. I'll take a look at that when I get back to my, after we get done with the live stream, I'll go through and make them available today. I don't know why they're scheduled for that time, because that doesn't make any sense. No, I definitely want to give you plenty of time to work with the test 3 material. Just fair warning, test 3 is the hardest test, short of the final. The final's hard, but hard in the sense like there's just a lot on it, not hard in the sense like the individual questions are daunting. Test 3 is daunting. I saw your question about question 13, but I'm not going to like do that during a live stream because I don't want to risk showing you like your grades and what's in there. So I'm going to respond to your email after the live stream's done. So I have seen your email, I just haven't had time to respond to it. Oh, also, before I forget, so we've been talking with Carolina Biological. A lot of you have suddenly got another email from Carolina Biological saying that your lab kits are further back ordered. We also got a weirdly cryptic email from Carolina Biological about that situation. So Thursday at 10 a.m. we have a department meeting to talk about what's going to happen with that. On our end, we're being very sympathetic, so you're just going to keep getting extensions and extensions and extensions automatically until we can figure out what's going on with these lab kits. What we are weighing doing right now, because Carolina Biological promised us last week everything would be showing up, and then they suddenly backed down on it, and they said, well, students can go buy their own chemicals, which kind of, like the chemicals that we're going to be missing from your lab kits are hard to find chemicals, which is why they don't have them. But short story is that we're going to consider giving you alternative lab assignments for those of you who weren't able to get the kits. We don't like that option because these are alternative assignments that are more meant for like if you're taking a CETA course and there's a hurricane or there's snow, it's kind of something that you can do from the comfort of your room, from behind your computer. You don't do experiments, but that's kind of the point. We want you to be doing experiments. These assignments are not meant to be a replacement for a lab kit, and that may be the position we're forced into. Another option we're considering is having you pair up online with people who do have kits and work with them and their data in order to like figure out, how, in order for you to actually be able to do the lab assignments. So again, we're still kind of weighing what to do Thursday. Hopefully we can come to a consensus. But yes, we became aware last week, like around Thursday, Carolina Biological sent us a weird cryptic email explaining why things are backordered again. And we're trying to figure out what to do. If you do not have a lab kit yet, and a lot of you are in communication with me about that, you're just going to keep getting extensions. And you're going to keep getting extensions until we either figure out how to get you a lab kit or we figure out what we're going to do in place of a lab kit. Now, those of you who were able to get a lab kit, good for you because you're actually doing experiments. And this is what we would much rather you be doing in terms of Chemistry 2. Chemistry 1, honestly, the in-course labs, they're okay-ish. But they don't start being like interesting and actual like what I would consider real chemistry experiments until halfway through the semester. With chemistry too, generally we hit the ground running with the second week by actually working with chemicals that are toxic, and you actually having to work with like things that require gloves and goggles. We would like to have that experience more in chemistry too. We recognize with COVID that we're kind of having to do lab kits. They're a substitute, but they're not a great substitute for a seated lab. It would be even a further disservice to you if you had to not only not get a lab kit, but have to do paper labs. So yeah, we're working on that right now. For those of you who don't have kits, you're just going to keep getting extensions and extensions until we can figure out what's actually going on with Carolina Biological. But yeah, don't worry. I'm not the type of instructor. It's outside your control. I'm not going to punish you for not having a lab kit because they don't have it. Refunds are another thing we're asking, and we also want refunds for the students who got the kits, because it's kind of nonsense that they paid for a kit and other students don't have to pay for a kit for taking the same course. So yeah, there's the whole, it's not just you guys getting refunded for never getting a kit, it's the people that were able to get a kit that suddenly paid more for a course than the other students taking the course. So yeah, we're going to try to keep this as equitable as we can for all students. Because again, some people got kits, and we would really rather them work with kits, but we don't want them to feel like, well, I paid all this money for a kit, and somebody who didn't get a kit didn't have to pay for the kit, and so I had to pay more for this course and they didn't. We don't want to create that type of disparity in the course. But we need to come to Carolina Biological with a unified front saying, hey, you guys kind of lied to us. You said you can meet these demands. You kept pushing back deadlines. We kind of are at a point now where it's looking bad for us. So yes, we are definitely talking refunds with them. We're talking about how we can get other students refunded if they've already got a kits, or at least give them a coupon or a discount. Because they assured us back in April they could meet the demand for these kits. Yeah, I think that's really the only big news right now, the whole lab kits. But Yeah, I'm here. I might as well make sure the test 3 stuff is visible. Any other questions out there? Oh, that is most certainly not what I told you to do. I remember being a student in college and really absolutely hating WebAssign with a passion. I thought it was clunky and I thought I didn't do a very good job. And then years later, I showed up and started teaching and realized it is even worse on the faculty side. I mean, what was also more alarming to me is that it has not changed its appearance since I was in college. And I remember when it was like a fairly new program. let's make sure everything else is set correctly in this course. Yes, it looks like WebAssign decided all my assignments need to be visible a week before they were due. Thank you, WebAssign. That's definitely not how I programmed it, but okay. We should be good now. Alright, so all your WebAssign homework should actually be available at the correct time again. How odd. Other questions? I'll give you about another 5 minutes. If no one's got questions, then we'll just kind of head out for today. Again, with exams, I'm going to try to have them graded within 1 business day. So those of you who submitted your exams yesterday have already graded your exams. So I'm actually looking at a lot of my emails right now regarding the tests. So what we're going to do is I'm just going to go ahead and, since no one's asked questions for the last 10 minutes, I'm going to go ahead and take off so I can start responding to those emails. So thanks to those of you that were able to show up today. Again, live streams are 4 days a week. So there's going to be one tomorrow, one Thursday. If you can't make the live streams, please shoot me an email. I'll try to answer your questions at the start of the live streams. This way you'll have to watch too deep into them. And I will see you all tomorrow.